Welcome students. Today we will study about the linked list. What is the linked list? Basically, a linked list is a collection of linear data types. These are the contents of our today lectures. We will study about what is the linked list, creating linked list, different type operation performed in linked list like insertion list, linked list. Insertion is also done in three patterns: inserting at beginning, insertion at end, and insertion at specific location. Similarly, deletion is also categorized in three categories: deletion at beginnings, deletion at end, and deletion at specific location. Now, what is the linked list? A linked list is a linear data structure made of chain of nodes in which each node contains a data and a pointer to the next node in the chains. So basically we can say that a linked list is basically collection of the node, and the smallest unit of a linked list is known as a node. A node is basically divided in two parts. First part is known as the data, and also it is recognized as a info field, and second part is known as a next field, and basically in the next field we will use pointers. So we can say a node is basically combination of two sections. First one's data and second one is pointer. So data is basically the information to which we want to process, and next field basically hold a pointer that points to the address of the next node to be connected. So this is the block diagram of a node. A node is divided in two parts: info field and next fields. Info field is basically a information, and next field is basically used to connect or point to the next. This is the block diagram of representing a single linked list. Basically these are the nodes, and this is the first node, and each node also have the address in the memory. So this node first have the address 1004, and next node address is 1006. So when we design a linked list, we always have to use a start pointer. This start pointer is basically hold the address of the first. This start basically hold the address of 1004, and this 1004 is basically address of the first node. Similarly, the next field of first node hold the address of the second node, that is a 1006. So this make a chain. One next pointer hold the next node, and again next node next pointer hold the again next node. So this process become continue, and they make a change of the nodes. And when the node is finished, then last node info part is defined as a null. It means now next pointer of this node cannot access or connect to the other node. And we also can say the node which address field is null, that denote the terminations of a node. So this is basically a block diagram of representing a single linked list. What are the basic difference between the arrays and single linked list? Basically, arrays are recognized as a fixed size, whilst the linked lists these are recognized like as a dynamic size. Next point is that insertion and deletions are insufficient in the array, whilst in the linked list insertion and deletion are efficient and no need to separate. Third point is that array use the random in elements in array we can access the randomly, but this process is not applicable in the linked list. Fourth point is that memory in array is mostly wasted when our array is not full, while in the linked list, our linked list is basically dynamic represented or created in dynamic way, so there is no memory wastage. Fifth point is that in the array, sequential access is faster while the sequential access in the linked list is slower. So, in sequential way we can fastly access in array, but this process is not applicable in linked list. Now, there are some basic operations which is implemented on the linked list. First one is creating a list, second insertion and elements in the list. So, inserting elements also have the different way, and third is deleting an element from. How we create the node? Basically, when we create the node, we always use the structure, and we know that structure is a data user defined data type, and that is the basically combinations of heterogeneous data type. So when we define the node also is inbuilt of two part. First one is the info, that is also known as a data, and second part is the pointer, that is known as a next pointer or link pointer. So using the structure, we design a node. So syntax of this is that we firstly use the keyword struct, then we give the name of the struct like as node, because we are going to create a node. So I will put the name of this struct like as a node, and required data is info or next pointer. So info is defined as a int data, and next pointer is defined here like as a next. So using this syntax or this code, basically in the memory there will make a block for the node, and this block is divided in two parts. First part denote the data, and second part denote for the links. Now designing this node, we create a pointer variable which type is the struct, because it is necessary to access any data. The pointer should be have the same data type. So our data type is basically struct. So our structure is also start pointer is also struct type. Basically, when we declare the structure, initially we start this pointer to the. When we use this code, this is block diagram which are represented in the memory. So according to our codes, there will be make a block that will divide it into sections. One part is data, and next second part is used for next pointer. So that is the visual representation of node according to our code. Now next point is how we create a linked list. Basically, we know that a linked list is a collection of node, and these nodes are basically connected to each other with like as a chain form. Okay. So when we create a linked list, we basically create a procedure create, and in this procedure we basically define two pointer variable ND and PTR. Here ND is a new node creation pointer, and PTR is basically a pointer which are used to process or access the elements of a linked list. So when we define new node, this new node pointer is basically used to create a new node, and using this statement or creating a new node, we basically give this statement and equals to struct node, then we use this pointer and malloc size of ND. Okay. So giving this statement, we basically design a new node, and this new node basically have the memory space in the memory, which is divided in two parts. First one is data and second one is info. So when we define this node, the next or next part of this node, in other words, we can also say that new node's next pointer will define as a null because that is the first new created node. So its next pointer will be defined as a null. Okay. Now, if we want to create more nodes and we want to links more nodes, then we have to follow these steps. If start pointer equals to null, it means our start pointer is always denote the first node, or if our first node is null, or in other words we can say our start pointer value is null or denote null, then we can say that there is no any element, so we have to create a node. So in condition of start equals to null, I will set the start equals to new created node, and PTR, that is the process pointer, that is also imply or denote the new created node. If our we have created more than one node, or in other words our linked list is not empty, then in this case we basically process the processing pointer PTR. PTR next becomes the node, and PTR goes to the new created node ND. Now that is the visual representation of our written codes. At the starting, if our node linked list is not empty, it means that have more than one nodes. In such a way, start pointer always denote the first node. Okay. And when we attach the new data, then this pointer will process the each element of the nodes one by one, and when we create the node, then PTR go here, and at the last node, the next pointer of the last node is always denoted like as a null. It means there is the termination of our linked list. There is the basic operations which are performed on the linked list: insertion and deletion. So insertion operation is also categorized in three categories. Insertion at the first node, or it is also known as that insertion at the beginning. So this is actually our given linked list. In this linked list, this is the first node, this second node, and that is the last node. So our aim is to adding the new node at the first node. So what are the process? As we know that start always denote the first node, so it is necessary that new created node's next pointer should be denote the start, and after connecting this we have to set start to the next new nodes. So this we will, there in next slide we will consider the algorithm of insertion at the first node of a new node. This is the algorithm insertion at the first node of a new node. This is a process of insertion first node. Here we take two pointers, ND denote the new created node and PTR used for the process of elements of the linked list. So using the ND, first we have to create the new node. As we create the new node, we basically set the new node next. It means the next pointer of the new node basically denoted by the null. If our start is not start equals to null, then in such conditions we our new node created new node is a start is set with the start pointer, and PTR is also set with the new created node. Otherwise, it means there are exist more than one node. In such case, when we have to create the new node at the beginning, then we have to set the new node next pointer to the start, and start is set with the new node. So that is the algorithm or process of inserting an element at the beginning or the first node of a linked list. Next is insertion at the last node. This is our given linked list. Our aim is to add at this last node, or after this last node we have to add new created node. So when we want to perform this process, it is necessary we have to reach the last node. After reaching the last node, we have to set the last node's next pointer to the new node, and new node next pointer is set with the null, and PTR is set with the new node. Now, algorithm of insertion a node at the last node. So that is our process. In this process, we basically take two pointer variable, new node and PTR pointer. First, we create the new node. After creating new node, we always set the next pointer of new node with null, and then we check the condition that our linked list is empty or not. If our start equals to null, in this situation we set the start equals to new node and PTR equals to new node. If our linked list is not empty, then this case we basically set PTR next pointer to the new node, and new node is set with the PTR. So that is the process of inserting a new node at the last. Next process is insertion a new node at a specific location in the linked list. So to perform this operation, we have to follow the three steps. First step is that find the position after which and before which node the new node will be inserted. Second point is that assign their locations to two different pointers named PTR1 and PTR2 respectively. Third point is that make the next pointer PTR to point the new node and next pointer of the new node to the PTR. So we will set these value and then we process our insertion operation. So this is the block diagram for representing the visual representation of inserting at the specific location. There is mentioned our actual linked list have the three elements, and we have to insert new element after the second and before the third. So we have to set two pointer according our mentioned points. PTR1 is set at the node 2 and PTR2 is set at the node 3. So after setting this, we apply the process that PTR next is set with new node and new node next is set with PTR. So using these statements, we can insert this new created node between the node 2 and 3rd. So we write the algorithm for inserting a new node at a specific location. So first we use here four types of the pointers. New ND denote the new node. PTR is pointer that is used to process the element of linked lists. PTR is pointer which is used to denote the before position of new inserted node, and PTR2 is the pointer that is used to denote after position of the inserting the new node. And pauses denote the positions where we have to insert the new node. So this statement is basically used to create ND equals to struct node pointer malloc size of ND is used to create a new node. When our node is created, after that new created node next pointer is set with null value. After that we check the condition for empty or not. If our start equals to null, it means our linked list is empty. In this case we basically set start equals to new created node and we set ptr with new created node. If our linked list is not empty, in such cases we firstly apply pointer ptr is set with the start pointer and then we apply a process of reaching the position where we have to insert the element. So I apply this instruction using this code for I equals to 1 and I less than pose and I plus plus. After that this process will go continue where condition is less than position. So ptr is set with ptr to ptr next, it means ptr is continue get growth, and similarly ptr2 goes ptr1 next, it means ptr2 basically denote the next node of the ptr1 and ptr1 next is set with the new node and ptr1 next node is set with new node and new node next is set with the ptr. So that is the process of inserting a new node at a specific location. Now our next operation is the deletions operations in the linked list. So deletion operation is also performed in three ways. First one is that delete at the first node in the linked list. So that is the visual representation of deleting the first node. That is the first node, that is the second, and that is the third node. So basically our linked list is contain the three nodes. Our aim is to remove the first node or delete the first node. So when before the deleting of start pointer denote the first node. So when I will remove the first node, then second node become the first. So in this situation we have to send start pointer to the second node. So how we perform this task? We use the algorithm. We use a delete first node process where we use two pointer. Temp pointer is used for temporarily hold the data and ptr is the pointer that processes the element of linked list. First, before the deleting I have to check that our linked list is empty or not. So if our start equals to null, it means our linked list is empty. So our linked list is empty, then I have to return from here. Else, it means our linked list not empty, then we set the temporary pointer with the start pointer and the start pointer is transferred from the next of the temporary pointer. So we can say that our start pointer goes to the second node and after reaching the start pointer at the second node, then we have to remove or free the first node because first node now is held by the temp pointer and I have to free this temp pointer. So that is the process of deleting the first node from a linked list. Next operation is deleting the last node of a linked list. So doing this activity we have to follow the two steps. First, we set the second last node next pointer to the null, and after that we free the last node. So this is our linked list. In this linked list, I have to remove this last node. So to remove this last node, it is necessary that I have to reach the second last node, and after reaching the second last node, I have to set the second last node next pointer to the null, and next of this will be free from here. So to implement this operation, we use the algorithm. So this is our algorithm for that denote how we remove or delete the last node in the linked list. So first I have to check the empty condition. So if the start equals to null, then we can say that our linked list is empty, and where our linked list is empty, then we cannot perform the deletion operation. Else we use here basically two pointer, first time pointer and next is PTR pointer. Time pointer is used for temporary hold the node. When we start the process, first we set PTR to the start pointer, and after that we check for the null condition. So while PTR next, it means next of PTR next is not equals to null, then we proceed the PTR to PTR next, and temp next temp of PTR to temp is processed at PTR of next. PTR next is set with null, and after that we basically remove or free the temp variable. So removing this temp variable or pointer, it means deleting the last node of linked list. Now our third process is deleting at a specific locations. So suppose that is our linked list, and in this linked list we have to remove or delete this node. So that is the process of deleting a node from the specific location. So it is necessary that we have to consider the position from where we want to remove the node. So to implement this operation, we basically use the algorithm for deleting at a specific location. So this is our algorithm. In this algorithm, we basically use empty pointer, PTR1 pointer, PTR2 pointer, and temp pointer. And we basically use a integer type variable in pos. This variable is basically used to denote the position from where we want to remove the node. So first I have to check for the empty. So if our start equals to null, then we can say that linked list is empty and we have to remove from here, or we have to return from here. Else it means our linked list is not empty, then we firstly set PTR1 to start pointer, and after setting PTR pointer we go to the at the position where we want to remove the node. So we apply here this statement. So using this statement, we reach the one node before the required positions, and after that we set basically PTR to PTR next, and temp is set to the PTR next. After that ptr next is set with the temp next. Now we have reached at the required node, and after getting this node we have to free this node pointer, or we can say this pointer. So we have to free this pointer, and after freeing this pointer we can remove the node from the specific locations.